It therefore seems quite natural to assume that we live in an Earth-centered or geocentric universe. Nevertheless, we now know that Earth is a planet orbiting a rather average star in a vast universe. Look at these assholes. Right off the bat, they're calling you average. Me and my dad were going through some old shit in a closet, and we stumbled upon this book right here, The Cosmic Perspective. It appears to be a standard, mainstream, heliocentric textbook, and I thought it would be a great idea to look through this book with you guys in real time, sort of flip through it. By the way, this book is from 2007. Let me find that copyright. Copyright 2007. So this book was written long before there was a flat earth resurgence, and long before these guys had any idea anybody was actually questioning their consensus. And so here we have it. Part 1. Our place in the universe. Bam! And here we are met with a sort of a rudimentary map of our place in the cosmos. Up here it says universe. And then we have our cosmic address, it says right here. So here's where the book really begins. I mean, it starts right here. Far from city lights on a clear night, you can gaze upward at a sky filled with stars. Lie back and watch for a few hours, and you will observe the stars marching steadily across the sky. Confronted by the seemingly infinite heavens, you might wonder how Earth and the universe came to be. Yeah. If you do, you will be sharing an experience common to humans around the world and in thousands of generations past. Modern science offers answers to many of our fundamental questions about the universe and our place within it. We now know the basic content and scale of the universe. You don't know shit. We know the age of Earth and the approximate age of the universe. Yeah, right. You don't know shit. And although much remains to be discovered, we are rapidly learning how the simple ingredients of the early universe developed into the incredible diversity of life and our modern view of the universe. If you observe the sky carefully, you can see why most of our ancestors believed that the heavens revolved about a stationary Earth. The sun, moon, planets, and stars appear to circle around our sky each day, and we cannot feel the constant motion of Earth as it rotates on its axis and orbits the sun. It therefore seems quite natural to assume that we live in an Earth-centered or geocentric universe. Nevertheless, we now know that Earth is a planet orbiting a rather average star in a vast universe. Look at these assholes. Right off the bat, they're calling you average.
And right before we jump into this chapter, I want to remind you guys that I have a fundraiser going for a Nikon P1000 Ultra Mega Zoom camera. I want to do a lot of great zoom tests here off the coast of Miami. And I think it's going to be really interesting to see whether or not I can find that ever-elusive curvature. I've done tests before with a measly pair of binoculars, and I was not seeing any curvature obscuring that lighthouse. So either way, the point is, I have a fundraiser out. I'll probably drop $300-400 down, but if anybody wants to chip in and help me get to this goal here for the Nikon P1000, the link is right there below. Let's jump into this book.
Let's read that again. Nevertheless, we now know that Earth is a planet orbiting a rather average star in a vast universe. They literally are calling you average because you orbit a rather average star. So by association, the fact that you live on a planet that's just circling around an average piece of crap, no big deal star in the universe, they've already minimized you from the start. They've already diminished your importance. They're already destroying your soul. They're already robbing you of your sense of value in the world. Right off the bat, this is hilarious. Our modern view of the universe. This is literally like the 4th paragraph in this damn book. Let's read that again because it's too good to be true. If you observe the sky carefully, you can see why most of our ancestors believed that the heavens revolved about a stationary Earth. The sun, moon, planets, and stars appear to circle around our sky each day, and we cannot feel the constant motion of Earth as it rotates on its axis and orbits the sun. It therefore seems quite natural to assume that we live in an Earth-centered or geocentric universe. My goodness. And we cannot feel the constant motion of Earth as it rotates on its axis. So this is incredible. I mean, this is what it comes down to, guys. They're telling you that you cannot feel. The Earth is rotating on its axis, but you just can't feel it. It's so true what I've heard other flat earthers say. That from the very beginning, they have got you literally not trusting your own senses. From the very beginning. And I don't know what the effects are of this on the human soul and our psyches and what happens and how we view the world and how we end up behaving. I don't know what the effects of believing in a heliocentric versus a geocentric flat earth model are on the human being. But I think it's safe to assume here that if the very place you take in reality, and they're telling you that you're actually spinning at 1,000 miles an hour, you just cannot feel it. It almost sounds like they're setting you up to be a complete bumbling idiot in life who literally cannot trust his own senses and his own instincts. From the very beginning, they are handicapping your ability to walk through the world as a vigilant, intelligent, and just a keen individual who knows how to navigate the world. Because from the very beginning, you have to believe in things you cannot see and feel for yourself. And I know that on some levels that can sound a bit ridiculous. You can be like, well, you've never been to Australia for yourself. You've never been to Japan for yourself. So if you've never seen it and felt Japan for yourself, how can you know what's there? And I get that, and I understand that argument to a degree. But we're talking right now about, we're speculating, why would they lie? You know, people always ask, why would anyone lie about the shape of the earth? Well, let's ask ourselves that question. Why would they lie about the most basic facts about our place in the universe? Well, to get you to believe that you cannot feel the earth spinning when it feels stationary, that literally is a massive belief system you have to place your faith into. And what could be the effects of believing in something you've never seen or felt with your own eyes? It's literally a religion. You literally have to believe in things you cannot see and you cannot feel. Oh yeah, you might see it spinning in a freaking some alleged NASA live stream or something. But you're not going to see it spinning or feel it spinning for yourself anytime soon. So they literally go in a tiny little paragraph, they summarize our stupid ancestors who had everything wrong. They then say the earth is spinning on its axis. And in the very next paragraph, they jump to, nevertheless, we now know that Earth is a planet orbiting a rather average star in a vast universe. So you're nothing in a big world where there's so much better than you out there. The historical path, I mean, just imagine, I don't want to harp on this too long, but just think for a moment the impact that has. Just think for a moment the impact that has on people as a collective across the globe. The impact that it has. Just think about the difference between you're a speck of dust circling an average star versus you're the center of the universe and everything revolves around you. Just as a matter of which belief system do you think, which worldview would the elite rather push onto the masses? You're a speck orbiting around an average star in a giant universe? Or it's a flat earth, stationary center of the universe, all built around this little special thing we're in? Answer should be obvious. The historical path to this knowledge was long and complex. In later chapters, we'll see that many ancient beliefs seemed to make sense in their day and changed only when people were confronted by strong evidence to the contrary. We'll also see how the process of science has enabled us to acquire this evidence and thereby discover that we are connected to the stars in ways our ancestors never imagined. Oh, we're connected to the stars. Yes. First, however, it's useful to have a general picture of the universe as we know it today. Yeah, as we know it today. It's probably going to change a billion times. What is our place in the universe? We can describe our place in the universe with what we might call our, quote, cosmic address. Our sun is a star, just like the stars we see in our night sky. The sun and all the stars we can see with the naked eye make up only a small part of a huge disc-shaped collection of stars called the Milky Way galaxy. Our star, they actually describe their galaxy as a disc-shaped. And they highlight this one section. We live on one planet, orbiting one star, among more than 100 billion stars in the Milky Way galaxy, which is in turn is one of billions of galaxies. And they just throw out the word B, the billions, and just say you got billions of stars and billions of galaxies, billions of all across the universe. Oh my God, they're just fucking trying to disorient the shit out of you. How did we come to be? According to modern science, we humans are newcomers in an old universe. We'll devote much of the rest of this textbook to studying the scientific evidence that backs up this idea of our universe. Oh wow, look, more shit. Our cosmic origins. Throughout this book, we will see that human life is intimately connected with the development of the universe as a whole. Number 1, birth of the universe. The expansion of the universe began with the hot and dense Big Bang. The cubes show how one region of the universe has expanded with time. The universe continues to expand, but on smaller scales, gravity has pulled matter together to make galaxies. Earth and life. By the time our solar system was born, 4.5 billion years ago, about 2% of the original hydrogen and helium had been converted into heavier elements. We are therefore, quote, star stuff, because we and our planet are made from elements manufactured in stars that lived and died a long time ago. So that's some Neil Tyson glorification stuff. Trying to wow you because you're made of stars. Because, you know, when you read this shit, you just end up like depressed and befuddled. So they have to give you, in the step 4, they have to give you, but don't worry about it. You're made from stars and you can get in a telescope and observe the stars. How can we know what the universe was like in the past? This should be fun. You may wonder how we can claim to know anything about what the universe was like in the distant past. Yeah, like billions of years in the past. Like, no, I don't know, 14 billion years ago. It's possible because we can actually see into the past by studying light from distant stars and galaxies. Light travels extremely fast by earthly standards. The speed of light is 300,000 kilometers per second, the speed at which it would be possible to circle Earth nearly 8 times in just 1 second. Nevertheless, even light takes time to travel the vast distances in space. For example, light takes about 1 second to reach the Earth from the Moon, and about 8 minutes to reach Earth from the Sun. Light from the stars takes many years to reach us, so we measure distances to the stars in units called light years. 1 light year is the distance that light can travel in 1 year, about 10 trillion kilometers, or 6 trillion miles. Note that a light year is a unit of distance, not time. Because light takes time to travel through space, we are led to a remarkable fact. The farther away we look in the distance, the further back we look in time. For example, the brightest star in the night sky, Sirius, is about 8 light years away, which means its light takes about 8 years to reach us. When we look at Sirius, we are seeing it as it was about 8 years ago. So, sort of still waiting for how this proves you guys can look 14 billion years in the past. The effect is more dramatic at greater distances. The Andromeda Galaxy, also known as M31, lies about 2.5 million light years from Earth. Sort of seems to me like everything they're assuming here in terms of how old the universe is based on their alleged knowledge of how distant these things are. But let's see. The Andromeda Galaxy lies about 2.5 million light years from Earth. Figure 1.3 is therefore a picture of how this galaxy looked about 2.5 million years ago when early humans were first walking on Earth. we see more distant galaxies as they were even further back into the past. Here, it's also amazing to realize that any snapshot of a distant galaxy is a picture of both space and time. For example, because the Andromeda galaxy is about 100 light years in diameter, the light we see from the far side of the galaxy must have left on its journey to us some 100,000 years before the light from the near side. In other words, a single photograph in figure 1.3 not only shows us the Andromeda galaxy, how the Andromeda galaxy looked more than 2 million years ago, but it also shows different parts of the galaxy spread over a time period of 100,000 years. When we study the universe, it is impossible to separate space and time. Can we see the entire universe? The fact that looking deep into space means looking far back in time allows us to observe how the universe has changed through time. Figure 1.4. The farther away we look in space, the further back we look. The farther back we look in time. The age of the universe therefore puts a limit on the size of the observable universe, the portion of the entire universe that we can observe, at least in principle. So far, so this is, some Hubble, this is not Hubble, but here's a little Earth-based telescope here. And then it shows you distances, far, farther, and the limit of our observable universe. So here it says 7 billion light years, and they call that far. Far. We see a galaxy 7 billion light years away. As it was 7 billion years ago, when the universe was about half its current age of 14 billion years. And then they say, okay, we can see further. Farther, we see a galaxy 12 billion light years away, as it was 12 billion years ago, when the universe was only about 2 billion years old. And then they look further, the limit of our observable universe. Light from nearly 14 billion light years away shows the universe as it looked shortly after the Big Bang, before galaxies existed. The limit of our observable universe. Light from nearly 14 billion light years away shows the universe as it looked shortly after the Big Bang, before galaxies existed. And then it says right here, beyond the observable universe. We cannot see anything farther than 14 billion light years away because its light has not had enough time to reach us. I might have to sit down and think about that long and hard, but something's not adding up here. Part of what's sticking out to me here is, whether or not time even exists. Either way, there it is. Oh, look what it is. The moon is the most distant planet ever visited by humans, yet on the 1 to 10 billion scale of the voyage model, it is only about 4 centimeters, 1.5 inches from Earth. Alright, so that is the end of this installment in chapter 1 of this book. Obviously, I still have many more pages to go just in chapter 1, but I've been going for quite some time now, so I'm going to go ahead and end this installment right here. And we'll continue in the next video right from where we left off and continue through this. We got some interesting stuff coming up, including how much we're spinning. It talks here about Spaceship Earth. You're not just sitting here. You're spinning around the sun. The sun is spinning through the galaxies, and it just talks about all that stuff. And I want to thank you guys for watching.
Here I want to remind you guys that I have a fundraiser going for a Nikon P1000 Ultra Mega Zoom camera. I want to do a lot of great zoom tests here off the coast of Miami. And I think it's going to be really interesting to see whether or not I can find that ever-elusive curvature. I've done tests before with a measly pair of binoculars, and I was not seeing any curvature obscuring that lighthouse. So either way, the point is, I have a fundraiser out. I'll probably drop $300–400 down. But if anybody wants to chip in and help me get to this goal here for the Nikon P1000, the link is right there below. Let's jump into this book.